Hello everyone. I don't see anybody. Any participants you can see there? How many are there? No, nobody is there. Top chat system. I don't see anyone here on the live session. If you have any questions, you can ask us. We didn't see any questions on the forum as well. Any specific question? Okay, a couple of forum questions which are asked. Just for the recording, I am going to try and go over it. Yeah, so this has been explained how to do the multiplications of permutation group elements. You have to do it systematically. You go from one initial configuration to the next configuration, apply another permutation operator. It's very straightforward. This has been discussed, right? You've seen it on the... Okay, the similarity transformation and conjugacy classes, it's exactly like if you do a element G and a conjugate element to it, let's say G1 is obtained by similarity transformation, then whatever you try to do as an expectation value, so basically trace of this operator does not change under similarity transformation, and most of the information you get on an operator and the similarity transformed operator, those two answers will be the same. Okay, so you don't get too much of new physics from two elements which are related by similarity transformation. So you can work with just one element from that collection of elements which are related by similarity transformation, and that is what we call it as a conjugacy class. Okay. Yeah. So this degree 3 symmetric group is just an anomaly in the sense that you could have taken the invariant subgroup which is EBB squared, or you could have found that the factor group which is EA can also be treated like if you do a factoring, then you get again a group. Okay. This does not continue for higher degree symmetric groups. So formally the factor group is defined as the group G divided by the invariant subgroup of G. Okay. So then all these cosets, collections of one element from each coset, they will all form a group. So this particular group of symmetric group of degree 3 had various possibility as an accident. It is not that it can be formally explained that G over any arbitrary subgroup H need not be a group. Okay, so the factors by any arbitrary subgroup will not give you a group. It turns out in this case it is a group. So keep that in memory when you do for higher groups. What is the difference between a direct product and a semi-direct product? Direct product is like you take one element from one group and another element from another group. The direct product, those two groups are commuting. Those two groups are commuting. So the elements also commute. So you can write, like for example C3H. You can write C3 cross another group which is identity and sigma H. Sigma H commutes with C3 elements. You can do C3 first and sigma H, or sigma H and C3. So in that sense C3H is a direct product. If you do D3, D3 is what? Is a dihedral group. You have a C3 as a subgroup. You also have the twofold axis identity and the twofold axis. Interestingly, you can see that the twofold axis rotation, 180-degree rotation about the twofold axis, and the C3, they don't commute. Okay? So you can show that the D3 is like a semi-direct product of the C3 group with another group which is E, the dihedral, the twofold axis rotation. Okay. Why the intersection of subgroups for a semi-direct product group is identity. So this is also important, like you try to take, suppose you take D3, it is the product of these two should give you the order of the group. So intersection between these two groups will only be the identity element. Difference between homomorphism and isomorphism is one example. So you can treat this for the factor group. Okay. So take a symmetric group of degree 4, and alternating group of degree 4 will be the invariant subgroup. If you take the factor group, you can show that the map is like a homomorphism with the identity element of the factor group related to the invariant subgroup on the other side. So you can show G to G mod H, where H is an invariant subgroup, and show it is a homomorphism with the kernel being this invariant subgroup. Isomorphism, the identity is mapped only to identity and the maps are 1 to 1 and 1 to 1. What is an alternating group and how to find a number of cosets for it? Yeah, whenever you want to find a coset, you need to find a subgroup and then write. You need to find the subgroup and then find the cosets. Okay. Just for a group you cannot write a coset. You have to find cosets with respect to some kind of a subgroup to write the group elements. Alternating group per se is symmetric group of degree n, you allow all possible permutations. Any permutation can be broken up into product of transposition. Alternating group is a subgroup of this symmetric group and it will involve only even number of transpositions. The group elements, permutation group element should be broken up into even number of transpositions. That is what is the definition of the alternating group. Okay, physical meaning of order and dimension of a Young diagram. So order is typically given to a group. What is the number of elements in a group? But when you look at a Young diagram, and if you are doing symmetric group of degree n, then you can formally find what is the dimension of a Young diagram. Young diagram is a diagram where you put number of boxes in the first row, number of boxes in the second row can be maximum equal to the number of boxes in the first row and so on. In decreasing order you can draw the diagram and the total number of boxes should be, for a symmetric group of degree n, the total number of boxes has to be n, and you know what is the Hooke number, and you can find the dimension as n factorial divided by the Hooke number. This has been discussed in the lectures. Okay. How do we find basis for the states for a symmetric group S3? So you can try to find this basis in the position coordinate system for the dihedral group. That's one way of writing it. Another way is to take three objects and see how the operations of group elements are that, and you can introduce the projectors and find the basis for it. Yeah, I don't see anybody else online. I'm a little surprised that nobody has shown up here. forum they ask beyond this?
No.
Probably this is a very specialized course that many of them are, whoever really wants to do is actually following the lectures. But if they have any doubts, they can come and ask here. If you have anything, you can post it on the chat and then we'll be able to answer. If there are no questions, then we may have to end the live session. Let's wait for another 4-5 minutes and then we will stop maybe. Probably tell them to come on. Tell that staff to come. No one is coming. Is the link the same or it is different?
No one is doing and no one is asking any question.
That is very surprising. Usually there will be at least 2-3 students to come. But this time I don't see anybody.
One person is asking me.
Yeah.
Okay. Yeah, so he is typing. Good. So he is typing it here.
How to look at a question? How to look at it?
Yeah, I just installation.
Yeah, just refresh it maybe. Whether only finite groups can be isomorphic to a symmetric group? Query from Abhishek. Yeah, symmetric groups are finite groups. I have a question in the question 7 of assignment 3. Will you be able to access it? See, every finite group can be seen as a subgroup of the symmetric group. Okay, Abhishek? But then you can start seeing them to be like the subgroups of the symmetric group are isomorphic to the finite groups. I have a doubt in question 7 of assignment 3.
I'm not able to log in. Actually, the doubt was that one more option was correct.
I see.
Yeah. So actually, I asked him to.
Okay, so what is the question? Do you know? You have it in your folder where I can see the.
Yeah, actually, the question was for D3H group, can we write it like the product of D3 and sigma H? So that option was not correct in the assignment. So we had a doubt that this is right. Why this option is not correct?
So it is not correct or it is correct? D3H is D3 cross sigma H is correct.
Yeah.
Okay, so we will re-evaluate it. D3 cross sigma H, the answers accepted in the solution does not match. I also posted this query. So the TA is here, Lekha. She will look into it and we will do the re-evaluation. Okay, Vivek. Okay, so we will answer this query in the Google group. Can you please enumerate the difference between order and degree of the group? Okay, order is the total number of elements and degree is how many objects you are going to do, you are going to play with in constructing the permutation group, or all possible permutations. So symmetric group of degree 3 will have that order of that group is 3 factorial, and the degree is 3. So 3 objects are getting permuted. Similarly, symmetric group of order of degree 4 means there are 4 objects which are permuted. So there will be order of that group will be 4 factorial. Okay, Abhishek? Okay, so we will re-evaluate it, Vivek, and we will update it. Okay. Anything else? I don't see others coming online, but probably they are asking questions through the forum, and Omkar is forwarding it here. Yes, so isomorphism is between two groups of same order. Otherwise, there's no point in doing isomorphism. Yeah, so this also has been explained in one of the assignment problems, that the group of all real numbers, which is where the group operation is addition, so identity element is 0, can be shown to be 1 to 1 and 1 to the group of multiplication of positive reals. Okay. So these are questions which were on offline, which also now I have answered. Any more questions from the people who are online? And we need to find out why students are not able to come to the live session. Probably we need to take some kind of a survey next time. What is a convenient time for them?
Actually, one student had posted a question that he was not able to join.
Oh,
Yeah.
so they are not able to join.
But I guess he later joined. He asked the question. Yeah.
He has joined now. Okay.
Yeah.
Only Vivek, right?
Yeah.
Okay. Nobody else. Yeah, probably the network was initially not working, and then he joined the same link and he could join, which means the link is working.
Yeah.
Adiba. Above were the questions from response sheet for live session. There was some technical problem. Okay. So Adiba is also joined online here. Any other thing we have missed, Adiba? Okay, so he had to join from a different browser. Okay. Okay, so next time maybe both of you, Adipa and Lekha, can try and find what is a convenient time for the live session amongst the students in the forum, and we could try and book that slot time so that all students who are taking this course can actually participate and clarify their doubts. Okay. So there are no further questions, and what's the time?
It's 5:30.
It's only half an hour over. I wish there were many students who could use this presence. Vivek, you have anything else to ask? So this question you noted down, right? The assignment 3.
Yes.
So please re-evaluate it. That is correct. You have to be given full marks. Yeah. We went through the questions in the list already and we answered it, and it is recorded. Whatever was in the forum, those questions we have tried to answer. Plus Vivek had a couple of questions. Abhishek from online, which was transmitted by Omkar, we had answered them also. Okay, so you can see me now, right, Vivek? I hope live is seen. But please post your questions, whatever doubts you have in the forum, and we will definitely answer. And monthly once, I'll make sure that we have a live session. Hopefully, a lot of students will join at least next month to clarify your doubts. Okay? Okay then, so we will end the stream today since there are no more questions you have and nobody else seems to be around. See you all next month, but please go over the videos in a very strict discipline of watching every week and solving the assignments and take the exams also. So that way you can make sure that you have understood the concepts clearly. Okay. Okay. Yeah, that's what looks like. There was some technical problem with the link, is what we all understand. And that's okay. So Nehika was here and we could go over the solutions. See you all. Bye bye. You can end this thing.